from LJ Institute of Engineering and Technology. Today's session we are going to discuss about Fourier series. Let's move to our class. Hello friends. Earlier lecture we have already discussed Fourier series of the function which are having period 2 pi, but there are many engineering problems where it is required to expand the function as a Fourier series over an interval of the length 2l instead of 2 pi. Let's start. We understand the change of interval means, first of all, in this method we have to first identify the value of l. Then we have to use this formula 2l equal to distance to identify the value of l. In this method we have range which is c less than or equal to x less than or equal to c2 to l, where l is any arbitrary periods. Means now our upcoming examples are 0 less than x less than 2l, 2 0 less than x less than 3, minus 2 less than x less than 2, minus 3 less than x less than 3, minus 1, 2, 1. These are the intervals. So whenever we have given interval in terms of arbitrary periods, then we first find the value of l. Now, first of all, we discuss about our range of interval is c to c plus 2l. Then our formula is a0 equal to 1 upon l. Instead of pi, we use l here. c2 c plus 2l f of x dx. Al equal to 1 upon l integral c2 c plus 2l f of x cos n pi x by l dx. Bn equal to 1 upon l integral c2 c plus 2l f of x sin n pi x by l dx. Finding the value of a0, a and bl. These are the Fourier coefficient. Substitute this value in this final Fourier series formula. a0 by 2 summation n equal to 1 to infinite an cos n pi x by l plus bn sin n pi x by l. In our example, here we use nx, that instead of nx, in this type of example we use n pi x by l. Now, if next one is, if our function is even. Already we discussed about how to find even and odd function. Then if f of minus x equal to f of x, then we can say that is even function, which is already discussed in earlier video and you already learned in this topic in 11-12 science. If function is even, then bn equal to 0. No need to solve bn, we put directly 0. But first thing we must be remembered, when we use even and odd function, then our limit is symmetric. Limit is symmetric. Symmetric means we have arbitrary periods minus l to l, means minus 2 less than x less than 2, minus 1 less than x less than 1. This type of interval is given in question. Then we use even and odd function concept. This type of function we have to check function is even or not. Then here if function is given, then Bn 0. Here we discuss about minus L to L, interval of minus L to L. Then A0 equal to multiply with 2. Then here we use 1 upon N. Then here we use 2 by L. F of x dx. And our interval is minus L. Then we discuss particular this interval. Means multiply with 2 and half of the interval. Then we find the value of A0, AN and BN in even and odd function to 0 to L interval. Suppose we have range minus 2 to 2. Then we discuss with 0 to 2. We consider only positive interval. Getting? Now, another formula is AN. Then interval 0 to L, f of x cos n by x by L. Now, our final Fourier series is f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos n by x by L. Just substitute the values of a0 and an, which is already 0 in this equation. If function is odd, if given function is odd, then how do we identify the function is odd? Then f of minus x equal to minus f of x. Then we can say that given function is odd. If it is odd, then a0 and an we put directly 0. No need to find a0 and an. We go for directly bn. And bn equal to 2 by L integral 0 to L f of x sin n by x by L into dx. And Fourier series is summation n equal to 1 to infinite an here sin n by x by L. Find the value of bn and just substitute the values of bn in this formula. These are the formula to finding the Fourier series which having arbitrary periods, means in terms of interval of range, means constant limit which is given in function or question. Let's start with one counter example. Find the Fourier series of the function f of x equal to x square minus 2. Here, interval which is minus 2 less than x less than 2. Then, first of all, we have to check the limits or interval of x, that is symmetric or not. Then here, limit is minus 2 to 2. Then we can say that is symmetric limit. Then we have to check given function is even or not. Then f of x equal to x square minus 2. Then replace x as a minus x. Then minus x square minus 2. Then we get x square minus 2. That is same as original function. Then f of minus x equal to f of x. Then we can say that given function is even. Here, given function is even. So, if it is even, then bn 0. No need to solve bn. Now a0. A0 we have formula 2 by L integral 0 to L f of x dx. Then we must find the L, that is length of function means we have formula 2l equal to distance, then 2l equal to, how we can identify the distance? Then according to the line segment, -2, -1, 0, 1, 2, then -2 to 2, then interval of that particular point, -2 to 2, that is 1, 2, 3 and 4, then 2l equal to 4, then l equal to 2, then we get value of l is 2. Suppose we cannot find this, then that is value of a and that is value of b, then we find just b minus a, then b that is 2 minus a minus 2, then 4, then here we get directly distance as well as b minus a. Otherwise you can find the interval of -2 to 2, this between the interval of this point -2 to 2. Now here we get l equal to 2, then substitute the values of l, then 2 by 2 interval 0 to 2, here function that is x square minus 2, this 2 which is cancel out, x square integral of x square that is x cube by 3 minus 2x 0 to 2, then upper limit minus lower limit, then 2 raised to 3 that is 8 by 3, 2 2s are 4, then 4 3s are 12, then 8 minus 12 divided by 3, then answer which is minus 4 by 3. Similarly, we have to find al, then formula is 2 by l integral 0 to l f of x cos n by x by l. Substitute the values of l, then here l equal to 2, 0 to 2, f of x that is x square minus 2 cos n by x by 2. Now 2 which is cancel out, this term which is indicated by u, this term which is indicated by v, then with the help of product rule, u as it is integral of v that is sin n by x by 2 upon n pi by 2 minus derivative of this term means 2x integral of this term, then minus cos n pi x by 2 upon n pi by 2 whole square plus derivative of this term, that is 2 minus sin which is carry forward, integral of cos that is sin n pi x by 2 upon n pi by 2 whole cube, here 0 to 2. Then we apply upper limit minus lower limit. Before that we just understand this thing, that is here we have sin n by x by 2, then we replace x as a 2, then here we substitute x as a 2, then 2 cancel out, then we get sin n by, then value of sin n by that is 0. Similarly, suppose cos n pi by 2 divided by 2, here we replace x as a 2, then 2 cancel out, then we get cos n pi, then value of cos n pi that is minus 1 raised to n. Similarly we replace x as a 0, then cos 0 1 and sin 0 0. This 4 value we require in upper limit minus lower limit, and upper limit x replaced as a 2, then first for here we replace 2 by 2, 2 cancel, then sin n by 0, 0 into anything 0, minus minus plus 2 into 2 cos n pi that is minus 1 raised to n upon n square pi 4 plus sin, here sin is negative but sin n pi that is 0, 0 into anything 0, then we written plus as well as minus in 0 term. We cannot find the value of this term, then because that is 0, then here substitute the 0, sin 0 0 minus minus plus, here replace x as a 0, 0 into anything 0, sin 0 0, then we get 2 2s are 4, 4 4s are, then 16 minus 1 is to n upon n square pi square. That is value of an. Here Bn equal to 0 because function is given. Then f of x equal to a0 by 2 summation n equal to 1 to infinite an cos n pi x by n. Substitute the values of n. Then n equal to 2. Here a0 equal to minus 4 by 3. Then we get minus 2 by 3. Summation n equal to 1 to infinite an. That is 16 minus 1 to n upon n square pi square into cos n pi x by 2. That is Fourier series. No need to expand this term. If our question given the also deduce that particular function or particular expansion, then and then we expand this. Otherwise, no need to expand or solve this. Next counter example is find the Fourier series of function f of x equal to minus 1 to 1. Here minus 1 less than x less than 0, 0 less than x less than 1. Here function which is in terms of arbitrary periods and limit which is also in terms of arbitrary periods, means function and limits both are constant. But here starting limit which is indicated by minus 1 and ending limit which is indicated by 1, then we can say that it is symmetric limit. If limit is symmetric, then we have to find even and odd function. Then better understanding for even and odd function, we use graphical method. Here minus 1, here 1. Then minus 1 to 0 interval. Then we have value of function, that is minus 1. And 0 to 1, we have function range is 1. Here, that is minus 1. Then our graphical representation is in range of 0 to 1, function having value 1, and this range of function having value minus 1. Then according to this diagram, we can say that f of minus x equal to f of minus x. Then our function is odd. How? Here suppose minus 0.5, here suppose 0.5. Then at particular 0.5, function having value 1. Then at position minus 0.5, then function having value minus 1. Then we have here value which is opposite sign. Then we can say that f of x equal to minus of minus f of x. So we can say that given function is even. Suppose we have function. This is our odd function. If function is odd, then a0 equal to 0 and n equal to 0. No need to solve this. We go for directly just finding the Vn. Suppose we have, for example, another function that is in terms of this range, means here 0, minus 1, or here 1, or amplitude of function, value of function that is 1. Then we can say that here that is our f of x, and that is our minus f of x. Then this type of function is given, then we can say that that is even function. Then f of minus x equal to minus f of x. Here function is odd, then we find just Bn. Then formula Bn equal to 2 by L integral 0 to L f of x sin n by x by n. Then first of all, we find the value of n. Then we have 2n equal to distance. Then here interval is minus 1, 0 and 1. Then 1 and 2. Then 2n equal to 2. Then n equal to 1. Substitute the values of n equal to 1. Then 2, 0 to 1 function. We use 0 to 1. then at particular this interval we have value of function that is 1, then 1 into sine n pi x by 1, then 1 into anything function anything, then sine n pi x, then integral of sine n pi x that is minus cos n pi x by n pi. Here 0 to 1, then upper limit minus lower limit, and substitute cos n pi, this minus comes outside the bracket, then cos n pi that is minus 1 raised to n, cos 0 that is 1, minus comes inside the brackets, and 2, 1 minus 1 raised to n upon n pi, that is the value of Bn, and substitute values of Bn, that is a0 equal a0 0 summation n equal to 1 to infinite Bn sine n pi x by n, substitute values of n and Bn that is 2, 1 minus 1 is to n upon n pi here into sine n pi x. Similarly, if we find next counter example, next counter example is find the Fourier series of f of x equal to x plus x square, interval is minus 2 less than x less than 2. First of all, here interval is symmetric, then we have to check given function is even or not. Then f of x equal to x plus x square, then replace x as a minus x, then minus x plus minus x whole square, then minus x plus x square. We replace x as a minus x, then we give the original function, but here we cannot get the original function. Then here f of minus x equal to f of x, this condition was not satisfied. Suppose minus which is common, then also we get x minus x square, then also we cannot get f of x equal to minus f of x. This is not an original function. Then if we replace f of x equal to minus f of x, then also this condition was not satisfied. Even though here limit is symmetric, then also we cannot get the satisfy the condition of even or condition of odd. Means we can say that our function is neither even nor odd. Means this type of function we find the value of a0, an and bn. Each and every coefficient we find in whole interval. Let's start with a0. Then a0 equal to 1 upon L integral minus L to L f of x dx, otherwise c to c plus 2l. Then value of c is minus 2. Then first of all we have to find 2l equal to distance, then 2l equal to 4, then l equal to 2, then substitute values of l equal to 2 and 1 by 2. Here limit minus 2 to 2, function that is x plus x square dx. Then 1 by 2, here x square by 2 plus x cube by 3, here minus 2 to 2, then upper limit minus lower limit, then 1 by 2, 2, then 4 by 2 plus 8 by 3 minus 2, that is again 4 by 2, here minus 8 by 3, then plus 4 by 2 minus 4 by 2 which is cancel out, then 1 by 2, 8 by 3, this both are then minus plus 8 by 3, then 16 by 3 into 2, then we get 8 by 3, that is value of a0. Similarly, we find an, then an equal integral minus L to L, otherwise C to C plus 2L. Here similarly limit which is C to C plus 2L. Here also C to C plus 2L f of x cos n pi x by L dx. Then here 1 upon L, then L that is 2 integral minus 2 to 2 f of x, that is x plus x square cos n pi x by 2 dx. This term which is indicated by u, this term which is indicated by v, that here 1 by 2 as it is, u as it is, integral of v, that is sine n pi x by 2 by n pi by 2 minus derivative of this term, then 1 plus 2x, integral of this term, then minus cos n pi x by 2 upon n pi by 2 whole square, plus derivative of this term, then 2 minus sine, carry forward, integral of this term, then sine n pi x by 2 upon n pi by 2 whole cube. Here minus 2 to 2. Then apply upper limit minus lower limit. Then upper limit, here we use sine n pi x by 2. Then upper limit, replace x as a 2. Then n pi 2 by 2 cancel out. Then sine n pi, that is 0. Similarly, cos n pi x by 2. Then we get cos n pi 2 by 2, which is cancel out. Then cos n pi, that is minus 1 is 2, and cos 0 1 and sin 0 0. Then substitute the values of upper limit and lower limit 1 by 2. And another formula, that is cos of minus theta equal to cos theta and sin of minus theta equal to minus sin theta. Then here 2 cancel, sin n pi 0, 0 into anything, 0, minus minus plus, then 1 plus 2 2s are 4. Here 2, then cos n pi, that is minus 1 is to a upon n square by 4. Here minus sin n pi 0. Lower limit, then minus sin of minus theta equal to minus sin theta. Then 2 cancel out, then sin n pi 0, 0 into anything, 0, minus minus plus. Here minus 2, then minus 4, and 1 minus 4 into cos of n pi, that is minus 1 raised to n upon n square by 4. Similarly, sin n pi c. Then 4 plus 1, 5, 5 4s are 20. Then 1 by 2, 20 minus 1 raised to n upon n square by square, minus, here also minus, minus plus, then 4 3s are 12, minus 1 raised to n upon n square by square. Then taking LCM, then 1 by 2, here 2, here 2, that is 32, minus 1 raised to n upon n square by square. Then 2 halves are, then 16 2s are, then 16 minus 1 raised to n upon n square by square. That is value of an. Similarly, you can find the value of bn and just substitute the values of a0, an and bn in our formula, which is f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos n pi x by L plus bn sin n pi x by L. In this formula, we just substitute values of a0, an, bn and value of n. That is our Fourier series. If you have any doubts regarding this topic, then feel free to contact me. Thank you so much for listening me.